Hi, this is Chrisferb and I'm going to review a Poisson example that is a little bit more difficult than the first example that I did. So if you haven't seen the Poisson number 1 example, then I would take a look at that video first. Okay. So a book publishing company has determined historically its books have 1.5 errors per 100 pages. So you'll see if you've seen the first video, this is the same type of setup as the last one. What is the probability of having 0 errors found in 400 pages? Okay, so this is a little different than the last one. So 400 pages. So our interval has changed. Our average, or our lambda value, is still 1.5. It's 1.5, and that's per 100 pages. But when we go down here and we do our time ends up being 400 pages. So instead of it being 100 pages, 400 pages, so our time is actually 4. And as I described in the last video, I used the Poisson parameter, which is known as mu, which should be familiar to you by now. So the mu is just multiplying lambda by the time, and that's what we're using as our average. So it's just a little bit of a easier package, I'd say, to use. So our mu for this one, if you do 1.5 times 4, then we end up with 6. So the last one, the time was just 1. So the time wasn't as important because we were looking within 100 pages, which was the interview of our lambda. But this one is 4 times as large of a interval. So now we actually have to change our time, and that's why we have the mu that's like that. Okay, so we're still looking for x, which is 0. So that's not much different. Okay, so I'm going to write out the formula then. So P, it's very similar to last time. Taking a couple shortcuts only because we are familiar this time. And then our E. So that's what the setup will look like. And when we plug in the values, our mu is 6, our x is 0, our E is a very long value, and it is 2. I usually go out 4 decimal places, 2.7182. And then to the negative of 6. And then 0 factorial. And then 0 factorial ends up being 1. So when we work this out, this ends up being 1. Then we'll just solve this top part. Well, the answer ends up being this. 0.00247. Okay, and that's it for this problem. I am not going over how to do it with the calculator only because we did it in the first video. So if you're unsure about how to calculate this type of problem, take a look at the first video and I'll explain, and it explains how to do it in the calculator. On the last video, I'm going to explain how to do this in Excel. So if you're interested in that, then keep an eye out for the last video. Thank you.